Okay, 1D from your predicting redox reaction exercises. I lied. 1E, we already did D. The steel of an automobile fender is exposed to wind and rain, and it says assume the steel is made mainly of iron. So it would be Fe solid. And I hardly left myself enough room there, but I'll go down a little more here. And it's exposed to wind and rain. So rain will be Fe2, or no, what is this? H2O, liquid. Wind, oxygen. If you want, you could put nitrogen in there and a whole bunch of other gases, but it's really probably oxygen that's going to be the important one. Okay, if we go to our redox table, we will see that Fe is an Ra. There's your Fe2 positive. There it is right here. So it's an Ra. Your water, of course, is an Ra and an OA. And O2, if you look for O2, starting at the bottom, not here, not here, not here, there. It's O2, it's linked with water. Here it's linked with H2 positive ions, but it's not acidic, so we're not assuming there's acid rain. Although, I mean, obviously there probably is in our world, but it didn't say that in the question. Continuing, and I'm doing this just because it's the first time we've used O, so it's nowhere else on this side. And it's nowhere in this side. So the only spot for oxygen is when it's linked with water, and that's an OA. This is both an OA and an RA. Oh, and while I was doing it, I should have pointed out there's no nitrogen anywhere on the table. So you can put it in if you want, but it doesn't matter. When we look to see which one is stronger, it will be the iron for the reducing agent by far, because it's way down here somewhere. Where'd you go, iron? There it is. And the water's up there. And when you look for the oxidizing, it's going to be the oxygen because the water's down here. Okay, so we write our two half reactions. So for our, oops, put the S in here. So for our oxidizing half reaction, it's going to be O2 gas plus 2H2O liquid plus 4 electrons going to 4 OH negative ions. And for the iron, Fe solid going to Fe2 positive aqueous plus 2 electrons. This guy needs to get multiplied by 2, and then we can add them together. So we'll have 2 Fe solid plus O2 gas plus 2 water going to, 2 Fe2 positive aqueous plus 4 OH negative aqueous. Go back to your chart. Here's your O2. Here's your Fe. OA is above RA. It is spontaneous. So right, spot here. All right, 1F. Says, in a research study on the prevention of corrosion, chemical engineers have removed dissolved oxygen gas from a solution by the addition of a basic solution of sodium sulfate. Okay, so there's oxygen gas in the solution, so there must be also water in the solution. Sodium in a positive aqueous, sulfite, SO3, 2 negative aqueous, and it says basic solution, so OH negative aqueous. All right, we already did the O2 out top, so this is going to be an OA linked with water. Water is both an OA and an RA. Sodium positive ions are all the way down here on the bottom. 1, 2, 3, 4, 5 up from the bottom. They're an OA. SO3, first time we're looking for SO3. So SO4, and you're going to find it on this side, I know, even though I'm pretending to look on that side. If I made the chart clearer so I could see it, I could help you find it. There it is. SO3 linked with the basic, the OH, okay? And then the OH itself, it's here linked with hydrogen gas, except we don't have hydrogen gas. But it's further up by itself, okay? So, linked, it's an RA, and then by itself, it's an RA. Okay, and now we need to figure out which one is the strongest. It will be this oxygen one again. And for the RA, it's going to be the linked one. All right, so O2 gas, I'm just copying it from above, 2H2O, liquid, 4 electrons going to 4OH negative, aqueous. And then the SO3 one is SO3 2 negative, aqueous, plus 2OH negative, aqueous, going to SO4 2 negative, aqueous, plus water, plus 2 electrons. So again, the bottom one is going to need to be multiplied by 2. Okay? And look what happens when I multiply the bottom one by 2. Not only are the electrons going to cancel out, but the OHs are going to cancel out as well. Okay? And so we'll be left with, when we add these together, O2 gas, and water. 2 water, and there's going to be 2 water. So they're also going to cancel out. So maybe I need to write it all down and then cancel them. So plus 2H2O plus 2SO3 2 negative plus 4OH negative going to 4OH negative aqueous plus 2SO4 2 negative plus 2H2O aqueous. Okay, so the 2H2O on each side cancels, the 4OH on each side cancels. You're left with O2 gas plus 2SO3 2 negative aqueous going to 2SO4 2 negative aqueous. Check out to see if it's spontaneous or not. The O2 is here. The SO is way down here. It is definitely spontaneous. Okay, that's number 1 now complete. Number 2 says, part of a design of a chemical analysis, as a part of a design, a chemical technician prepares an acidic tin 2 chloride. Acidic, which means there's going to be H positives. And we're going to run out of time. Tin 2 aqueous, chloride, Cl negative, aqueous, solution, H2O, liquid. Will the solution be stable if stored for a long period of time? Okay, so we've already done H positive, it's an OA. We've already done Cl, it's an RA by itself. and an RA linked with water. Water is an RA and an OA. And if you remember